Hey everybody, I'm back. It's April 15th video. Please make sure that you have uploaded on the Google Docs your April 14th information. You guys, we need to get you guys full participation points, and I'm going to be, remember, giving out the answer key the day after. So while you're watching this, you guys should have already done April 14th, uploaded that in the Google Docs. You can get full participation. Then please make sure that you are checking over the answer key to April 14th homework, seeing if you guys need help. It's impossible for me to check everybody's individual homework problems and see exactly how they're doing. I have 130 students, so I need you guys to be checking your own work and then reaching out to me if you need some help, all right? So make sure you guys do your part. Okay, today we're gonna be doing 3 more problems about adding or subtracting radicals. Hopefully yesterday kind of made sense, and then you can build off that and get a little bit better. So whenever we look at a plus or a minus problem of radicals, the first thing we do is we see if we can reduce radicals. Well, we notice that all of these radicals are the same, so either they all reduce to be the same or they all stay. And 7 is a prime number. There would be no pairs if we did prime factorization, so it stays trapped. But the key to unlocking this problem is the first term has an invisible 1 in front of it. So whenever you're adding or subtracting radicals, you simply add or subtract the numbers in front, leaving the radicals the same. So I'm going to just look at the numbers in front. 1 plus 5 makes 6, minus 4 makes 2, but my answer can't simply be 2. It has to be 2 times the square root of 7, or 2 rad 7. When we look at number 2, if you're thinking about just the simple basics of it, the radicals are the same, we can add or subtract them. You might think those can't be added or subtracted because they have different radicals. But remember, step 1 is try to reduce each radical. 2 is a prime number, so you wouldn't be able to break that up with a factor tree. But 8 is a composite. 8 is 2 times 4. 2 is prime, so you're done with it. 4 is 2 times 2. They're both prime, so now you're done. And remember what we look for in square roots. A pair comes out as a single, and a single stays trapped. So I have a pair of 2's and a single 2. So the pair gets to come out though. A pair of 2's gets to come out as a single 2, but when you look or you draw your arrow on the outside, there's already a 9 there. Oh, sorry, I forgot to tell you, just rewrite 3 rad 2 at the beginning. So the 3 rad 2 comes down. There's a plus sign. But then the second radical part actually does reduce. So the 9 times the 2 that you brought out is 18. You put your square root symbol and you look at what is still trapped. That single 2 is still underneath the radical, and now they look like terms. That is a square root of 2, that is a square root of 2, so we simply add or subtract the numbers in front, leaving the rad 2. 3 plus 18 is 21, rad 2, and we are done. All right, you guys, your final example for today before you guys try your practice problems is number 3. And please remember, you guys can always pause, rewind, rewatch any of this video until it makes sense. Or you can pause and try to work ahead and see if you're getting the right answers for these as well. Number 3. We're gonna have 6 rad 3 plus 5 rad 6 minus 3 rad 12 minus rad 24. Okay, right now it would look as though there are no like terms, none of them can be added or subtracted together. But I have to see if the radicals break down or not. So 3 is a prime number, so rad 3 is gonna stay the same. So this guy right here stays 6 rad 3. There's a plus sign. Well, 6 is a composite number, but when we break it down to prime numbers, there's no pair. So the 2 and the 3 both stay trapped. 2 times 3 is 6. So this radical stays exactly the same. Just because underneath the square root, which is called the radicand, by the way, the radicand is composite, doesn't mean that it's going to reduce. And then there's a minus symbol. 12 is a composite number. It's 2 times 6, and it's 2 times 3. Prime, prime, prime. So I look at the prime numbers and I notice a pair. A pair of 2's gets to travel outside as a single, but there's already a 3 out there. So 3 times 2 is 6. I keep the square root symbol and I look at what was trapped. This prime number was a single, so the 3 stays on the inside. Now there's another minus symbol. And rad 24. 24 is a composite number. So it's 2 times 12. 2 is prime. 12 is 2 times 6. 2 is prime. 6 is 2 times 3. 2 is prime and 3 is prime. So once you get your prime factorization, you look for pairs and singles. A pair of 2's gets to come outside. Single 2 stays trapped. Single 3 stays trapped. So on the outside, I have a 2. I put a square root symbol, and on the inside, a 2 and a 3. 2 times 3 is 6. So now I look for like terms. Well, I can see that I have 6 rad 3 minus 6 rad 3. Now, 6 rad 3 minus 6 rad 3 makes nothing. 6 minus 6 is 0, so you have 0 rad 3's or none. Now, if that was the only part of the problem, you'd have to put the 0. But since there's going to be something else, we just say that these cancel. They don't make anything. But we look at what we still have then. And you guys, 5 rad 6, it's positive, gets to combine with negative 2 rad 6. So I add or subtract the numbers in front, and 5 minus 2 is 3, and I keep my rad 6 as my final answer. All right, you guys, I hope that helps. Hopefully you're getting a little bit better at adding and subtracting radicals. Here are the 3 problems that I'd like for you to try on your homework. Please remember though, you should have a brand new sheet of paper. It should be dated 4/15. You should have the 3 examples that I did as well as these 3 examples so you can upload them to your Google Docs on classwork. After I show you guys these, I'll say goodbye, but it's your boy, Mr. P. Hope you guys are doing well. Here are your 3 homework problems. Let's let it zoom in there. All right, you guys can pause that, write them down, and try them out. All right, have a great day. Bye.